The Best of Our Knowledge explores topics on learning, education, and research. An invasive insect, the emerald ash borer, poses threats to America's forests. A federally supported study is using parasitoid wasps to control the arboreal pests. And we'll visit an environmental science professor in the field as students collect trail cameras as part of a national study on mammal populations. I'm Lucas Willard, host of The Best of Our Knowledge. You are listening to The Best of Our Knowledge. I'm Lucas Willard. The emerald ash borer is unmistakable. It's a small, bright, metallic green insect that feeds on ash trees. It's also a pest responsible for the loss of tens of millions of trees in the U.S. EAB, as it's known, was first found in the United States in 2002 in Michigan. In New York, the insect was first found in 2009. And in 2020, emerald ash borer was discovered within the boundaries of the 6 million acre Adirondack State Park. Now, researchers there are trying to find ways to reduce their populations through the use of biocontrols. The Nature Conservancy's Adirondack Park Invasive Plant Program has released 3 species of parasitoid wasp on a property in the central Adirondacks, with hopes that they will prey on and reduce the population of EAB over time. It's also not the first time the organization has studied the impacts of biocontrols. For the last decade, the program has released beetles to manage an invasive plant called purple loosestrife. To learn more about how wasps are being used to control emerald ash borer, I spoke with Becca Bernacki, manager of the Adirondack Park Invasive Plant Program's EAB Biocontrol Program.
Yeah, so there are a few things that cue us in to look at a tree further for emerald ash borer. We look for declining canopy. We look for what we call blonding, which this time of year when there's no leaves on the tree is great to look for. And what happens is woodpeckers actually go after that larvae, and they take their feet and kind of scrape off the bark. So the bark gets this really blonde appearance that can be seen from pretty far away. They'll also get what's known as epicormic shoots. So as that vascular tissue within the tree dies, the tree actually sends off branches really low, and these shoots come out so that the tree can try to get those photosynthates down to the roots. And those are all things for us to look closer. If we see those, there are different things that can cause that, native insects and the like, stress. But once we get close to the tree, you're kind of alluding to those D-shaped exit holes. So the only pest that's going to leave those D-shaped exit holes on ash trees are emerald ash borer. And they're going to be about the diameter of a pencil, I like to tell people. So look at your pencil eraser, kind of cut it in half, and that's what you're looking for. The other thing that's really diagnostic for emerald ash borer is, the bark will start peeling away, or you can peel that bark manually, and you'll see these really S-shaped or serpentine galleries that kind of zigzag all over, like your toddler had a crayon and drew all over. Native pests will form galleries, but they're going to be a lot more linear.
So there are a lot of signs that point to an EAB infection. What can someone do if they spot any of these signs on their property, or say they're out raking the leaves one day and they notice some strange markings, or one of their trees doesn't look so healthy? How do they get this confirmed? What should they do?
Yeah, so in most counties in New York, emerald ash borer has long been established, so you can report it to DEC, but it's not gonna, raise to the level as it would in a new county. So if you're in one of the Adirondack counties other than Warren County, report it to us here at APIP. My number's on our website. You can drop it into IMAP Invasives. IMAP Invasives is a great tool. It's a mobile app you can download, and you can take pictures. Those pictures actually get sent to researchers and managers like myself, and we will actually go in and confirm them. You can report it to DEC Forest Health. Again, depending on the county you're in, you'll get kind of a different response. But those are all great options. But if you're seeing those D-shaped exit holes, it's pretty much a sure thing that's what's happening. I will say, our native pests are going to leave circular holes, and sometimes those can get obscured as woodpeckers kind of change the shape of them, trying to get those insects under the bark. But, if you're seeing 2 or 3 in the same area, it's probably going to be emerald ash borer. especially if you're in a county where it already is.
How important are ash trees in the Northeast and specifically in the Adirondack Park, both economically and culturally?
So ash trees don't make up a huge percentage of our trees here in the Adirondack, so that's a great thing for us. I'm from Western New York. Everywhere north of the 90 there, you're getting, stands that are 80% ash. Obviously, that's a huge impact. For us in the Adirondacks, most of our ash trees are going to be kind of bordering streams. That's where we see them the most. They're kind of in those stream corridors. So there's some stream shading issues that can happen when we lose them. Economically, the biggest place we see impacts for ash trees are street trees. So many communities went through and planted ash trees as their street trees, 20 or 30 years ago. And, those trees become hazard trees. Ash gets super brittle when it dies. So there's an economic impact associated with removing those trees. So, we have an ecological impact, we have an economic impact, and then we also have the cultural impact. Ash trees are, we like to say as American as baseball. Ash is one of the main woods that baseball bats are made out of. In addition, the Akwesasne and other tribes in our area use black ash, which can be killed by emerald ash borer, in their traditional basket weaving. And one of the things that's really interesting here is black ash isn't super common in New York. We certainly have it. We have stands of it. We have a couple stands I'm following. But we don't quite know how quickly it's killed by emerald ash borer like we do with white and green ash, which are much more common. And more importantly, we don't know if the genetic resistance is there to emerald ash borer. So in white ash, they believe that 1 in 1,000 trees is genetically resistant to emerald ash borer. So that gives us a lot of hope for breeding genetically resistant trees. But we don't know those numbers or even have the beginning of a basis of understanding of that for black ash yet. So I'm actually doing a community science project with the Ecological Research Institute, studying some of those plots so that we can start to get some of those answers.
So the Adirondack Park Invasive Plant Program is involved in research that is using a special kind of wasp to help control EAB populations. What can you tell me about this wasp?
So there's 3 that we're releasing. 2 are actually parasitizing the larvae of emerald ash borer, and 1 is parasitizing the eggs. So we're kind of coming at it twofold, right? Not only are we parasitizing those eggs to get rid of them before they become larvae, for those that don't get parasitized by what we call the Uubius agrilli, the egg parasitoid, those emerald ash borer will then hatch, become larvae, and then there's 2 stingless wasps, Spacius gleani and Traxtinus planopenisi, that we're releasing that will parasitoize those larvae. So, any invasive species management we do, the more tools we have in our toolbox, the better, right? So we're increasing our tools because we're using this biocontrol, but we're also coming at emerald ash borer on 2 fronts, attacking both the eggs and the larvae.
Where are these wasps actually from? Are they from an area of the world where EAB actually originated?
Yeah, so EAB is from Asia, and 2 of these, so Uubius agrilli as well as Traxtinus planopenisi are from China, and Traxtinus is actually from kind of the Russia-China border. So areas where emerald ash borer is native, and where these biocontrols evolved right along with emerald ash borer and have been able to keep their numbers in check.
When it comes to biocontrols, like using these wasp species to control EAB populations, is it risky? Are there any inherent risks to using one kind of animal to keep another kind of animal in check?
Thankfully we can stand on the shoulders of our predecessors and kind of learn from their lessons, right? So when spongy moth first got, introduced accidentally way back when, we released all of these biocontrols without studying them first. It was the early 1900s. We didn't know what we know now. And, some of these things cause some slight problems, none of them huge problems. But there are examples out there of biocontrols that were released without being studied and causing future problems. We learn from that, we make mistakes. And we've come a really, really long way from that. So now these things are studied in an incredible amount of detail to make sure that they are not going to cause problems in our habitat. So these things aren't going to influence our native insect populations because it's not a pest that it's not an insect that they want to prey upon. They're only preying upon the emerald ash borer. So there's a lot of research and R&D that goes into these before they get released to ensure that that doesn't happen.
Will these wasps be preyed upon by native species like birds or other animals?
Yeah, it's very likely, they are there. They're their food source. Birds are going to eat what they find. But they are very, very tiny. I mean, these wasps are, probably smaller than a dime, and most of them is legs and ovipositor. There's not a lot to them.
So people don't have to worry about hikers and others who are in the Adirondacks don't have to worry about being stung by a new kind of wasp.
No. These, we hear wasps and, we picture hornets in yellow jackets, but these are very, very tiny stingless wasps that are, just attacking emerald ash borer larvae and eggs.
So, Becca, what can you tell me about the scope of this study? Do you have a number of approximately how many plots are being monitored or how many wasps themselves are being released? What's the scope of the research?
Yeah, so this research is actually run by U.S. Department of Agriculture, and what they do is they are able to rear or generate enough biocontrols each year to supply 150 sites per year. And each site that is approved, so there's a process you have to go through, new states are prioritized, new counties are prioritized to help spread these around. They're able to approve 150 of the sites every 2 years. Each site's going to get biocontrols for 2 years. So we got our first biocontrols this year. We will get them again next year for the same site. Because of the way the research works, 2 years ago we applied. We didn't get selected because they were only able to select 30 new sites. Last year, because of, again, how things ramped up, they were able to select 120 new sites to keep them at that 150 number. So we're really excited to get accepted. So each year there are about 150 sites. I'm not quite sure how long they've been doing this. It's fairly recent that are receiving these biocontrols all across the U.S. And what happens is in year 3, we enter a monitoring phase, and we'll actually go out and survey for these biocontrols. So we can peel bark off of trees with emerald ash borer and see if we can find them in the larvae. And we can use these yellow pan traps that look like big yellow frisbees to see if we can find them in there as well. There is some research starting right now looking at how far these things are spreading, and that research is really exciting because they're kind of filling gaps in New York where the biocontrols haven't been released yet.
So do you think that there's hope that EAB can one day be under control in the U.S.?
I think, I'm really excited that between the biocontrols and the research that's being done in genetic resistance for ash trees, that, ash aren't going to go, the way of elm trees. We learned a lot and we've grown a lot, and I'm really hopeful. I think, we may see a decline over the next 10 years as it takes these biocontrols time to ramp up. But I'm really hopeful, in 20 years, we're still going to have ash on our landscape, and it's still going to be a prominent tree in American forests.
Becca Bernacki is the manager of the Adirondack Park Invasive Plant Program's EAB Biocontrol Program. The parasitoids were produced and supplied from the United States Department of Agriculture's Animal and Plant Health Inspection Service Plant Protection and Quarantine EAB Parasitoid Rearing Facility in Brighton, Michigan. Parasitoid information is available by calling 866-322-4512. You're listening to The Best of Our Knowledge. I'm Lucas Willard. While participating in a national study, one environmental science professor at Siena College is wasting no time in getting his students out of the lecture hall and into the field. The best of our knowledge's Jody Cowan ventures off path to bring us this report.
On a breezy and sunny November afternoon, students Lowell Nugent and Maddie McQuillan Slocum trek through the Albany Pine Bush, one of New York State's largest pine barren preserves, in search of a small, box-shaped trail camera.
You see that box right there? So we're just going to do our...
Stepping off the guide path, the students walk through thick layers of fallen leaves and over logs of downed trees into the dense underbrush. The camera is one of 15 motion-sensing trail cams spread across the 3,200-acre pine bush that Siena College students taking Professor Dan Bogan's environmental science course have been tasked with retrieving. The class is participating in Snapshot USA, a nationwide study that uses a network of mounted cameras to document the mammal populations present in the suburban, urban, rural, and wild regions of each state. Bogan placed his cameras for study about 6 weeks ago throughout both the Albany Pine Bush and the Dyken Pond Environmental Education Center in Grafton. This is the 5th year Bogan has worked the Snapshot USA project into his introductory course for environmental studies and science. In addition to looking at the history of environmental change across the country, the course engages students in ethics, differing worldviews, and the motivations of what inspires people to actually study the environment. Speaking with Professor Bogan on the trail at the Albany Pine Bush, he told me that in collaborating with Snapshot USA, he hopes to introduce his students to the concept of getting outside and in the field immediately.
A lot of other places actually engage their undergraduate students with this project, but it's typically for maybe a 300 or 400 level wildlife class. I'm challenging these students as freshmen, getting their feet wet and getting them out in the field, learning some important skills that will translate to some of the upper division courses. And also, we have 2 study sites, whereas many other places only run 1 study site. We have a comparison between the Albany Pine Bush here, where we are today, and we have a comparison site out on the Rensselaer Plateau near Dyken Pond. And that gives us a comparative study between basically a wildland area where there's not lots of natural habitat and very few people, to the Albany Pine Bush, which is a natural preserve, but it's embedded in a more suburban landscape. Taking a look at these 2 study sites, and I rotate the students through so they get to go to both study sites. And from here, even though we've collected the data, now they have to formulate some hypotheses about the differences in the species and abundance of what we're going to find. That's for our lab, that's for a part of my research, and then we have the macroecology questions. And so this study is leading to peer-reviewed papers. They are contributing to scientific investigations. It's just a win-win, really.
How did you first get involved or hear about the Snapshot USA project, and how have you been able to integrate it into your course?
Well, it started in 2019, before the pandemic. I was approached by Roland Case, who used to be the state mammologist at the New York State Museum. And I also worked with him for my master's, so we know each other quite well. And he reached out to a few of us here in New York State and said, hey, we've got an idea for a project. What do you think? Do you want to participate? And I thought, this is great. I can definitely see how I can integrate this into my classes. Some of the first assignments are just to talk about what the overall project is. I have them look at some of the websites for Snapshot USA, and they read about the projects, and then we get out and actually just jump right in, really. They start using GPS units for navigation in the field. They become familiar with how to use a camera trap, where trail cam hunters, wildlife enthusiasts will use them frequently just to document wildlife. We use it in a systematic way, the way we deploy here in our 2 study sites, but it's also the same basic way that people are deploying the camera traps across the United States. That allows us to have that consistency so that we can draw comparisons between all the different study sites.
That's pretty phenomenal, and I was curious about how many different, what things were kind of variable and what were kind of controlled. Certainly as we're looking at from state to state, this data collection.
Yeah, so there is some flexibility with the way that we deploy the cameras. Some people will use a fairly random approach and use random locations, and the cameras have to be anywhere from no more than 200 meters apart up to, I think it's 5 kilometers apart. So they can be spread out pretty far. I elected to have a really tight grid, which is rather different from many other study sites, but I did that with the idea that when we first deployed these cameras, I wanted to really keep tabs on small mammal populations. And this small grid is still at a scale that is, the locations are mostly independent. Chipmunks, squirrels, mice documented at one camera site are going to be different from the other sites that we document. If we get deer pictures or coyote and fisher pictures, it's probably very likely it could be the same animals because their range, the area that they live in, is so much larger than the grid that we're using here. So there's a lot of flexibility with the scale that the cameras can be deployed, but that's about it. So we usually target somewhere above 400 camera trap nights. That's one camera set for one night. And I use 15 cameras as part of the study. And so we end up running the cameras anywhere from 4 to 6 weeks. And it generally works out to close to about 5 weeks, and we hit the number.
What learning opportunities do you feel are present here, and what do you hope that students kind of take away from getting out to the field and just taking the class?
One of the first things in particular is that they can start to develop their self-confidence in being able to get out and participate with a systematic study where they're participating with a national study. And they get that street credit too. They have something that they can put on their resume right from the beginning that they've participated with the study. But there's a number of different skills that they're building. There's teamwork, collaborating, working with each other in a coordinated way. That's an absolute must in the environmental field. But also navigating with a GPS unit is very helpful. Using tools to collect the data for ourselves. Camera traps are wonderful because they stay in place, we leave, and the camera stays to record the animals in a way that we kind of assume is mostly not influencing the animal behavior. If we were standing there, the animals would not approach. So that's really cool. So they get to start using different tools and techniques for the environmental type of work that we do. One of the cool things too is they get to actually use artificial intelligence to help identify the animals that are in the photo. So we're using a program called Wildlife Insights, and that's being developed by Google and a whole lot of wildlife researchers. And so we get to use that program. Through this whole process, we very well may collect somewhere around 30 to 40,000 photos. And that's a lot to sift through. And we will take a quick pass and try to eliminate any kind of blank photos. But then having AI give the first identification for us really helps expedite. And then they'll go back through and correct some of the identifications.
Any surprises or specific challenges to kind of participating in a nationwide study like this?
One of the challenges, which actually ended up becoming a strength of this study, was the pandemic. And so we first started in 2019, and I continued to teach my classes at Siena College in person, face-to-face, socially distanced, and of course we had to take all the precautions. But out here, we had a bit more freedom. People still wore masks in the fall of 2020, but we were able to move about and feel more comfortable and be active. Active learning is a big part at Siena College, and it's just makes learning so much more fun when we can actually be on site, out doing something to learn about the environment and really tie into all the different concepts that we have for the class. One of the challenges, though, is that I selected the sites and the study design thinking that this was snapshot one time, and then we decided to continue the whole project. And I might have changed the deployment knowing that we are going to do this for a longer period of time. But then to maximize the deployments, I put the cameras in the same exact locations every year. That becomes a challenge because every year it's a new group of students. And so I've come up with a pretty good way of getting the students to find the site. GPS units help, but they're only so accurate. And then they have to try to align the camera to the exact field of view. And so that's the trick. And so we work on that a little bit. Now that we've got 5 years of data collected, I actually want to sit down with a couple independent study students and have them do a comparison. I want to, I'll be a strong member of the team, but we will work all together and try to quantify how good we were at getting the exact same field of view, measure the percent overlap, and then see not only how that habitat changes over the 5 years, because there's a lot of active management here at the Pine Bush to maintain this ecosystem, but there's also natural decomposition or regeneration and growth. So I want to see how each of these sites changes over the 5 years, and then how that influences our detections of the different species. So that's one of the near-term kind of things that I want to learn.
So you touched on kind of the future kind of endeavors for this data for your students. What's next as far as this project?
I will use a core team. I call it the core review team. We're going to take a look at the photos really quickly and eliminate any kind of blanks. And they're not necessarily blank, but there'll be photos where maybe there's a branch with some leaves that just keeps blowing in front of the camera. And we'll eliminate most of the false positives so that we don't upload those. We will upload, and then in 2 weeks, the students are going to be looking at the photos using Wildlife Insights, which is an artificial intelligence type program that will identify the species. They have to make some corrections, because there's definitely some corrections from time to time, and have frequency of occurrence and then species richness measures. And so they are challenged with coming up with predictions on what the difference is going to be between the mammal population here and the mammal population on the Rensselaer Plateau.
And I know that you mentioned that your students are kind of looking at this for the first year and this data on the first year.
Yep.
What kind of conclusions can you draw from the data set collected over the last 5 years, locally or nationally?
Well, nationally, there's some really interesting patterns going on. We are here in the Northeast forested biome. There are people that are working in the desert Southwest and the grasslands, and the mammal populations seem to really stick pretty well to some of those biomes. Not all animals, like coyotes live across North America, and they show up in urban areas all the way out to some of the more rural and mountainous areas too. For us, between the two study sites, it's been really interesting to see how similar these two sites can be. The pine bush is a unique area. It's a very large but fragmented natural habitat that's actively maintained by the preserve. And what's fascinating about that is that it is an important reserve for wildlife. So in this site, we've seen everything from what looks like maybe a long-tailed weasel, maybe a least weasel. It's a really small weasel, like the size of a mouse, on upward to fisher, lots of coyotes, different hawks and owls too can be photographed. And so there's a lot of parallel species showing up in the two sites. The cameras are really good at defining what species are here and then the relative frequency of how often that we detect. And from there's some really intense models that are starting to get at being able to estimate density, which is like the gold standard that everyone is trying to measure.
We just heard from Dan Bogan, professor of environmental studies at Siena College. For the best of our knowledge, I'm Jody Cowan.
This has been The Best of Our Knowledge, episode 1730. The Best of Our Knowledge is a national production of WAMC Northeast Public Radio. Thanks to associate producer Jody Cowan. The latest on all National Productions programs is available via the Airwaves newsletter and our flagship station's website, WAMC.org. Until next time, I'm Lucas Willard.